All right, so Pythagorean Theorem is chapter 7, section 1, 7 short slides that we have to look forward to, okay? What is the Pythagorean Theorem? And hopefully this is something that you've heard of before, but if not, here it is. The square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs, or a squared plus b squared equals c squared. God bless you. A and b as legs are interchangeable, but c must be the hypotenuse, okay? So C has to be the side opposite the right angle, which is the longest side in the triangle. So these are some common triples. Triples are three sides that when you plug them into the Pythagorean theorem, they always work, okay? The three whole numbers, basically. So if I gave you the side lengths of a right triangle were 3 and 4, you can automatically gather that the hypotenuse is 5. If I gave you 6 and 8, you can automatically gather that that third side is 10. 5 and 12 leads to 13, and 7 and 24 leads to 25. Just don't get this confused. Like if this is 4 and this is 3, is that missing side 5? No, what would be wrong with that? It's not the hypotenuse, it's not the longest side, right? You can't put a leg as 5 and the hypotenuse as 4. Does that make sense? So hypotenuse has to be longer side. If this 4 was here, now I can automatically assume that it's 5. And if I plug it in, 3 squared plus 4 squared would equal 5 squared.
The other one was false?
Correct. So these are just kind of shortcuts that will save you some time. If they're not triples, then you plug it into the equation. So if I look at A, it says that one leg is 5, the other leg is 10, and Y is the one that's missing, which is my hypotenuse. So since A squared plus B squared equals C squared, I would say that 5 squared plus 10 squared equals Y squared. What's 5 squared? What's 10 squared? $125 equals Y squared. And then to solve for Y, what do? What's the opposite of squaring? Square rooting. So Y would equal the square root of 125. With me so far? Now I've got to simplify that radical. So I use my factor tree. What two numbers multiply together to give you 125? 5 and 25. And 25 would be 5 and 5. And so each pair of numbers, one goes to the outside, which means I can bring out 1, 5, and that other one would stay underneath.
Why is it 5 and square root of 5?
So when you break down 125, you get 5 and 25, and then 25 breaks down again to 5 and 5. And for a square root, you need 2 of the same number to go to the outside. So 2 5s go to the outside of a square root as 1 5. And then there's still 1 left underneath.
Wait, how do you, get rid of the 5s? Because there were 3.
Right, so 2 of them go to the outside as 1, right? Because 5 times 5 would be 25. Square root of 25 is 5.
Oh, okay.
Yeah, you just skip that step. For every pair of numbers, 1 goes to the outside. All right, you do B. Actually, set up B. Which one's your hypotenuse? Y. So what's 5 squared? 25. When you have an expression squared, do I distribute that? Does that become Y squared plus 1? Can I distribute an exponent to an expression? What does that really mean? Is this the same thing as this? No. You can't distribute an exponent to an expression. So if inside the parentheses was just two things being multiplied together, I can distribute it in. But if there's a plus or minus in there, making it an expression instead of a single term, I have to expand it and FOIL it. So I would do y minus 1 times y minus 1. And then I got to FOIL it. So first, outer, inner, last. I'm going to multiply those first. So I get 25 plus y times y, which is y squared. Outer, negative 1 times y, which is negative y. Inner, negative 1 times y, which is negative y. And last, negative 1 times negative 1, which is positive 1. And then I want to combine my like terms. So 25 plus y squared minus 2y plus 1. And then combine the 25 and the 1. 26 plus y squared minus 2y equals y squared. Now what? Do I have like terms?
Yeah.
Which ones?
Y squared.
So if I combine them, I want to move this to this side. What happens? They cancel out. And then I still want to isolate my variable, so I can add the 2y to the other side. And then divide by 2. We're getting a lot of algebra thrown back in there. You've got foiling, combining like terms. It's a good and a bad, right? Good for review. Bad if you don't remember it. So A could be X or it could be 3. But I say A is X. B is 3, and then 3 square root 2 squared. So when you're squaring something, you're saying multiply it times itself, right? So this is 3 square root 2 times 3 square root 2. So when you've got a mix of numbers and square roots, you want to multiply the ones that are just numbers, and you want to multiply the ones that are square roots. So I'd get x squared plus 9 equals, and I do 3 times 3, which would be what? 9. And square root 2 times square root 2, which is what? It's 2, right? So any square root times itself is just what's underneath, or if you look at it as square root 2 times square root 2 being square root 4, it goes back to 2. So either way you look at it, you should get the same answer. So then I get x squared plus 9 equals 18. Subtract the 9. X squared equals 9, and then square root. So technically in algebra speak, that should be plus or minus 3. But is it possible to have a side length of a triangle that's negative 3? No. So we rule out the negatives and just keep the positives. So the two numbers that are outside the square roots I multiply together, and then the two numbers that are under the square roots I multiply together.
But wouldn't it just cancel out?
The root cancels out. So 3 times 3 is 9, and then square root times square root of 2 times square root of 2 is just 2.
And what if it was... Oh, so it's always just going to be the same number?
Because we're squaring. Yeah. If it was like 3 root 2 times 3 root 5, I would do 3 times 3, which is 9, and then root 3 times root 5 is square root 15. So it wouldn't simplify. But this you're squaring, so it should go away.
How is the bottom side the same size? Like the same length as the...
So it could be an isosceles right triangle.
Well, yeah, but like, it doesn't look like...
They're not going to be drawn to scale. So it's actually a really good question. He said it doesn't look like an isosceles right triangle. It doesn't have to. So unless it says drawn to scale, always assume it's not. Okay? But yeah, this would technically be an isosceles right triangle if these two were the same. Okay, so some application of it now. Find the length of a diagonal of a rectangle with a length 8 and width 4. So I'm a visual person. I like to draw the rectangle. So it says the length is 8, the width is 4, and I want the diagonal. So what's true about the angles? Oh, that's a really bad straight line. What's true about the angles in a rectangle? Alexis. These would be right angles. Obviously, without that, we couldn't use the Pythagorean Theorem. Okay, so they're going to be something involving a right angle. So this would tell you that these both are 90 degrees, so it wouldn't matter if I put the 4 or the 8 on the top or on the bottom. I've made 2 right triangles, and I have the legs. So what's the equation to set it up? 4 squared plus 8 squared equals the diagonal squared, which we can say C. You call whatever variable you want. So 16 plus 64. Can I simplify that? What two numbers multiply together to give you 80? 8 and 10. And then 8 could be 2, which is 2 and 2. 10 would be 5 and 2. And I need 2 of each number to bring it to the outside.
You bring 2 2's outside?
Correct. So there's 1, 2, second 2, and this 5 that doesn't have a match stays underneath.
Is that a multiplication sign between them?
Yep. So if you bring out more than one number, you're going to multiply it. And if you leave under more than one number, you're going to multiply them. Let's say instead of doing let's say instead of doing 8 and 10, we broke it down into something else. So what other two numbers multiplied together to give you 80? 4 and 20. So 4 and 20. And 4 would be 2 and 2. And 20 could be 2 and 10. Or it could be 4 and 5, right? Doesn't matter. I keep going until I can't go any further. That's how I know I've gotten it to the product of primes, right? These are all prime numbers. And then do the same thing. There's 2 2's, so 1 goes to the outside. Another 2 2's, 1 goes to the outside, and the 5 that's left underneath. So it doesn't matter how you break a number out. It will always end up the same, okay? At the end, when you get to those prime numbers, they're always going to be the same numbers. All right, so this says the diagonals of a rhombus have lengths 16 and 30. Find the perimeter of a rhombus. I just think it's so interesting that your book does this every once in a while because we haven't talked about rhombuses, right? Right? So a rhombus is a 4-sided figure that has all 4 sides the same. Okay? So a rhombus kind of looks like a diamond, if you remember a diamond, right? But all 4 sides have to be the same. And then one of the properties of a rhombus is that its diagonals bisect each other.
Isn't that just a square?
No, they don't have to have right angles in the corners.
Oh.
So a rhombus and a rectangle together make a square. If a rhombus and the rectangle had a baby, it would be a square. Which you'll learn all about. I think that's next chapter. See? Yeah.
Oh.
Okay? But we're getting a little preview here. So what you know about where the diagonals crisscross is that they cut the diagonals into 2 equal parts. So this one's going to equal this one, and this one's going to equal this one. And there's a right angle. So you've basically formed 4 right triangles. So if this whole diagonal, let's say, is 30, then that means that this is 15 and this is 15. And if this whole diagonal is 16, then that means that this is 8 and this is 8. So I basically have so we basically have 4 congruent right triangles, 8 and 15. So then my Pythagorean theorem would be 8 squared plus 15 squared equals c squared. Was this on your triples list? Yeah, right. So this is 64 plus which is 298, or sorry, 289. And the square root of 289 is 17. So roots like 13 squared and 17 squared are prime numbers. Those are going to be harder to know. You want to kind of memorize those because 289 you can't find any other way than knowing that 17 goes into it. It's not like you can break it down because it's even or it's divisible by 3. And this is also a triple, so if you wanted to add it to your list, 8, 15, 17, I probably would have added that. Okay, last one. So this is a triangle. I've got one big triangle, and then I've got, what's that line, what segment called, where it goes from the vertex to the side opposite at a right angle? Altitude, okay? And what kind of triangle is the big triangle? Isosceles. So if the altitude is drawn from the vertex angle of an isosceles triangle, that altitude is also the median, and it's also the perpendicular bisectors. So what does that tell you about that top length being 6? What happens where that right angle hits? It gets cut into 2 equal parts. So this is a 3, and this is a 3. And now I've got 2 congruent right triangles. So to solve either one, you can pick either one, the one on the right or the one on the left. I would say that 3 squared plus 6 squared equals x squared. 9 plus 36, 45. And then square root it. And break it down. So what 2 numbers multiply together to give you 45? 5 and 9. And 9 breaks down into 3 and 3. So this becomes
3, 5.
good. 3 radical 5.